Good day, and welcome back to Tech Tips, Fixes, and More. I'm Ron. Today we're going to be working on a Bose 402 Series 2 speaker array that was sent to me by a church. The speaker I received was reported to be cutting out and sometimes cutting back in. Now, I'm not sure why, but I seem to be getting a lot of these intermittent problems sent to me lately. So let's just jump into this thing and we'll see what we can find out. Bose 402s are a few years old now, but they're still a good compact speaker, and they use some of what I think of as unconventional designs to get a lot of good sound out of a small speaker with a number of high-quality speaker drivers. I don't understand all the science behind them, but it seems that Bose often uses small powerful drivers, frequency response shaping, and physical design to get a pretty good sound out of a small package. Okay, so here's the speaker, and allow me to just wax eloquent for a couple of minutes here on some of this theory. Those of you who already know about this kind of stuff, some probably better than I do, feel free to tune this out for now. And I do like to think that we have some subscribers that are new to this area, and I guess my years as an electronics instructor like to take over from time to time. So this is actually a pretty small speaker array. It's just 4.5 inch speakers in a vertical line. When you mount speakers in a vertical line, interference patterns cause the distortion of the sound to be kind of narrowed, and the sound doesn't spread out as much in the vertical plane. And that's good because it minimizes sound bouncing off or being absorbed by the floor and the ceiling of a room, while still allowing it to spread out side to side. In the earlier days of sound reinforcement, inline speaker arrays called columns were used widely. The Bose uses that, except they add a few more tricks to it. Another characteristic of speakers is that high frequencies tend to be beamy. So whereas low frequencies are omnidirectional, that means that higher frequencies don't spread out much, so that if you're off axis of the speaker you won't hear the high frequencies as well. The low frequencies, on the other hand, spread out much more easily, but it's also much more difficult for a small speaker to create low frequencies. For lows you either need a bigger speaker, or you have to have smaller speakers that can handle more power. So there's quite a bit more to this than that, but those are some of the simple basics that relate to this. Now, while I don't totally understand all the science used in Bose speakers, it appears that they improve the beaminess by mounting the speakers on angles. The middle two speakers point inwards and the outside speakers point outward. They also use an unusual crossover. Crossover is a frequency shaping network that allows some ranges of frequencies to be attenuated, while other ranges are passed without attenuation. The Bose speaker has a crossover network that consists of 20 microfarad capacitor in series with two small incandescent lamps, which is kind of weird in itself, which are in parallel. The whole network's connected across or in parallel with the top and bottom two speakers in the array. As near as I can tell, this creates a bandpass filter across those speakers, which shunts some of the highs and some of the lows around those speakers, allowing them to send out the mid-range frequencies more so. I assume this, in conjunction with the speaker mounting scheme, must provide control over frequency response and dispersion, but I'm not quite sure how it does it. Okay, so I've got this Bose 402 speaker array on my bench here, I have taken the top off, or the screen off of it, and exposed the speakers. And this speaker, you can look up the manual for it online. Bose has a 402 Series 2 loudspeaker manual, and it's actually quite good. It's got some information about the parts. It's also got a parts list for the crossover in there, and an actual layout of the crossover. There's disassembly procedures in here. There's also a schematic of the actual crossover and how the wiring of the speakers is. And there's test procedures that allow you to do a phase test, a crossover test, a rub and tick test, an air leak test, and a sweep test. So that's helpful. But this speaker seems to be acting intermittent, and it doesn't seem to be a mechanical problem. It seems to be a problem with where when the signal is increased, all of a sudden you get a louder sound coming out of the speaker. And my initial guess was that maybe we had a problem with this crossover. The other possibility is some kind of a problem with the coils in the speakers themselves. If it isn't a mechanical intermittent where you can wiggle the wires and it cuts out, then those would be the other two possibilities that I would consider. Okay, so what I've done here now is I've taken two of the speakers out of the cabinet so that I could reach in and get to the crossover. The instructions on how to get into there and get things out is all in this loudspeaker manual from Bose. I took them out and then I wrapped these speakers in foam and put a cardboard cover over the top. These are very expensive speakers, and I didn't want anything to get out of control and accidentally puncture a speaker. So I've got the speaker. The speaker has the 4 drivers and it's got the crossover. What I've done is I've taken my a function generator and put it on a sine wave output. I've got it set up right now for somewhere around 700 hertz. The output of my function generator I've got plugged into this little amplifier. It's a pedal board amplifier that I picked up from surplus, and it's not the best amp, but I use it for a test amp and it works okay. So this amp then I'm driving out of the speakers, speaker output, I'm sorry, and into the input connections on this speaker. Okay, so here's a situation where I was bringing up the signal at about 500 hertz, and all of a sudden it cut down to about half the volume that I could hear, and it didn't change the voltage across the input terminals. Now I'm just trying to see if any kind of movement will change that. So as I pursued the problem, I used my signal generator and a small test amp to put the signal into the speaker network. And I did find that when I increased the signal slightly, occasionally it would get significantly louder. I was having trouble narrowing down where that was coming from, and so finally I decided to disconnect the speakers and eventually narrowed it down to speaker number 3. I tried measuring the resistance of speaker number 3, and initially it was 10 ohms or less, and tried putting a signal directly into it, and I tried to measuring the resistance again after that, and the resistance had actually changed. It was more than 10 ohms, and then it eventually was 100 ohms, and so it was jumping around, and it seemed that probably the voice coil inside was shorting between windings possibly. So at that point, the only conclusion I could come to was that that speaker was bad. I compared it to the resistance of all the other speakers just to make sure they were correct, and they were all measuring about 1.4, 1.5 ohms, which is about correct for a 2 ohm speaker. So in the end, the only course of action was to order a new speaker, and I contacted Bose and was able to order one and get it within about a week. Okay, so we're finally, after a few days, getting back to this Bose speaker. I had to order in a replacement driver for it. Bose was pretty helpful. I made a phone call to them, and they shipped it to me. So I'm going to install this in there, and we'll do some testing, and I think that will resolve the situation. I sure hope so. I may have mentioned before that the wiring system that they use in these speakers is a little different than I've seen in most speakers, and maybe that's just a Bose thing, or maybe I'm just not familiar with all the ones, but this one they're using solid core wire, and they're also using wire wrap around these posts that they put in here, and that, you know, I guess it's a very reliable system of making good connection and doing it quickly, but I'm not all that fussy about the use of solid core wire. I fixed an old solid state amp a number of years ago that was actually a kit amp, and the guy that put it together used solid core wire in all of the interconnections on this board, and that amp was continuously failing because of the vibration of moving it around. The wires would wiggle until they would finally break off or go intermittent in some way. So I bought the amp and then fixed it continuously for the next several years before I finally got rid of it in disgust. And so since then I haven't been very trusting of anything that's built with solid core wiring like that. But that being said, this speaker is meant for permanent installation. It's not meant for road use anyways, and so that could be one of the factors in them doing it this way. If anybody is familiar with Bose or the use of solid core wiring and wire wrapping in speakers and equipment, I'd be glad to hear from you in the comments. So anyways, when I took this out, I just snipped them off, and I left a little bit of a pigtail on there because I wanted to be able to reconnect them if necessary. So when I put in the new one, it does have the same kind of a system of pins to wire wrap to, and I'll probably I don't have a proper wire wrapper for that, so I'll probably wrap around and then I'll solder onto it. Just being careful that I don't overheat anything or cause more damage than I solve. So, okay, so I've got the speaker wired in. Bring up the amplitude on the signal generator. And before, what was happening is sometimes it would be very low and sometimes it would all of a sudden take off, and that was because the one speaker driver was intermittent. With intermittents, it's always somewhat difficult to be 100% sure that you've got the problem. When I measured the resistance of the faulty speaker, it was, sometimes it was measuring 10 ohms, sometimes it was measuring 100 ohms, because there was some kind of a physical defect in there, an intermittent in the coil probably. And these coils on a meter should, well, they're measuring about 1.4 ohms. Okay, I'm going to put the screws back in this thing, button it up, and give it one more test, and then we'll get it back to the customer. So here it is. all put back together. I'll just put some signal on it again. Seems pretty good. I think we'll call that a wrap for this one. Thanks for tuning in, and if I can just leave you with one final, more general and esoteric thought, I want to say that I can't fix everything, but I've learned and come to know someone who can, and that's God. And if you're looking for answers, I suggest and encourage you to look to Him. He's got the answers, and He will help you through whatever it is you're going through. So thanks for tuning in, and we will talk to you on the next one.